Hey everyone, welcome to this explainer. Today, we're unpacking the reality behind artificial intelligence. Since you're probably already familiar with the basics, we're going to move pretty fast through the foundational stuff and spend our time dissecting some cutting-edge, PhD-level research on AI deception. Let's strip away the sci-fi hype and look directly at where the data is actually taking us.
Here is our roadmap for today. We'll start by demystifying AI, then break down the categories and types, and look at some real-world applications. After that, we'll push into the frontier with theory of mind, and finally, wrap up with building responsible AI. All right, part 1, demystifying artificial intelligence. So, let's start with the classic sci-fi question. Is AI actually conscious? I mean, the illusion of empathy from modern chatbots is incredibly convincing, right? But we really need to draw a hard line here between Hollywood fiction and actual computer science.
There's a massive myth out there that AI possesses genuine feelings. But the reality? It's far more clinical. As experts from Google Cloud point out, AI is really just a highly sophisticated pattern-matching machine. It doesn't feel joy when it solves a complex problem, and it doesn't get tired. It's simply identifying complex mathematical relationships buried inside absolutely colossal datasets.
Let's do a super quick refresher on how we actually got here. It all starts with Alan Turing's famous test back in the 1950s, leading to the official coining of the term artificial intelligence at the Dartmouth Conference in 1956. But notice the massive gap after that? It really wasn't until 1997 that IBM's Deep Blue defeated Garry Kasparov in chess. And that specific victory paved the runway for the 2010s, where an explosive growth in computing power triggered the generative AI boom we're living through right now.
When we talk about AI, we're operating across 3 stages of capability. Currently, absolutely everything we use, no matter how impressive it seems, is what we call narrow AI. That means it's strictly task-specific. Stage 2 is artificial general intelligence, or AGI, which is where a machine learns and thinks at a human level across literally any domain. Then, stage 3 is artificial superintelligence, which vastly surpasses human cognition. But to be clear, right now, we are still firmly planted on step 1.
Moving right along to part 2. Categories and types.
Let's explicitly contrast 2 of the major powerhouses in the field today. Think of predictive AI as a brilliant forecaster. It analyzes historical data to predict things like stock trends or when a piece of factory equipment might fail. Generative AI, on the other hand, is much more like an artist. Using deep learning, it actively generates completely novel content, whether that's text, images, or code that simply did not exist before you asked for it. And this generative technology is exactly what powers the conversational AI we interact with every single day. By utilizing natural language processing, it comprehends human inputs, breaks them down into tiny pieces called tokens, and generates responses that mimic human speech perfectly. It has honestly become the ultimate user interface.
Which brings us to part 3, real-world AI applications.
If we look at 2 massive sectors, say healthcare versus finance, we can really see how unique data pipelines are revolutionizing operations. In healthcare, the ultimate goal is better patient care, which is largely driven by analyzing sensitive medical imaging to accelerate disease diagnosis and even drug discovery. In finance, it's a completely different ballgame. It's all about better money handling, digesting millions of real-time transactions to execute algorithmic trading and pinpoint fraudulent activity. To put that into some concrete terms, AI isn't just a quiet back-end tool anymore. It's actively acting as a teammate. It's spotting early signs of lung cancer on medical scans that human eyes might completely miss. It's providing patients with 24/7 help via virtual assistants. Over in the banking world, it's identifying and freezing real-time banking fraud the exact millisecond it happens, and automatically evaluating credit risk. This is the true immediate power of narrow AI in the real world.
All right, part 4, the frontier, theory of mind.
Now we're going to dive into a psychological concept that computer scientists have basically borrowed, known as theory of mind. This represents a massive, massive leap from reactive tools to proactive agents. Think of it like this. It's the difference between a machine fetching a glass of water because you explicitly pushed a button and a machine bringing you water because it infers you're thirsty after seeing you come back from a long run.
In what we call multi-agent systems, AI is literally beginning to infer intent. By modeling beliefs about beliefs, an artificial agent can start to navigate really complex social dynamics. It learns to anticipate what another agent is going to do based on what it thinks the other agent believes. This allows for a level of incredibly sophisticated coordination that traditional, rule-based programming just cannot achieve.
And you guys, this is where it gets incredibly fascinating. Drawing directly from a 2025 PhD thesis out of Carnegie Mellon University, researchers are actually using theory of mind as an intrinsic reward for AI models in highly complex games, like poker. To win, these agents are actively tracking an opponent's beliefs, essentially trying to read their mind, and intentionally acting to confound them. So, this emergence of deceptive behavior, it's not a glitch at all. It's a highly evolved strategy to outmaneuver humans.
Which naturally leads us to part 5, building responsible AI. To safely manage these increasingly proactive systems, Microsoft developed a framework consisting of 6 core human-centered practices. It demands fairness and inclusiveness to actively prevent bias. Things like reliability, safety, and privacy, those are completely non-negotiable for protecting users. But perhaps most crucially, we have transparency and accountability. Organizations absolutely must be able to explain how their neural networks make decisions, and at the end of the day, humans must remain responsible for the final outcomes.
So that leaves us with a pretty provocative question. Are we ready for an AI that understands our intent better than we do? As AI evolves from reactive tools into proactive agents capable of inferring and potentially even manipulating our beliefs, we are entering completely uncharted territory. Seriously, think about that the next time you casually type a prompt into a chatbot. Thank you so much for joining me for this explainer, and keep your curiosity focused.